Welcome all of you. Welcome to this video of Maths Made Easy. Now in this video I am going to take up similarity, only the portion where we do relation between areas of two similar triangles. Okay, so there are sums which you must be knowing by now, that there are sums which are only about relation between two similar triangles. So there are two theorems in this chapter, okay, on which the sums are based. First, we are going to take up the first theorem and do sums on that, and then we are going to take up the next theorem and then take up sums with that. So please watch the video till the end, because you are going to find sums based on two theorems here. Okay. So here the area of two similar triangles are proportional to the squares of their corresponding sides. This is the first theorem. Now what does it mean? If I have one triangle which is A, B, C, and I have another triangle which is P, Q, R, and they have told us that triangle ABC is similar to triangle PQR. It is already declared. Only then, okay, or if we can prove by some method, only then we can say that area of triangle ABC by area of triangle PQR is equal to ratio of the squares of the corresponding sides. Means proportional means the ratio between the areas will be equal to the ratio of the squares of their corresponding sides. So if that means AB is corresponding to PQ, so length of AB square by PQ square, and then length of BC square by QR square, and length of AC square by PR square. Okay, so these are the three ratios. You can make use of any one of them. Okay, so this is the main theorem. We are going to do sums based on this. Okay, so this is the first question. The ratio between the corresponding sides of two similar triangles is 2:5. Find the ratio between the areas of these triangles. So here area of triangle 1, if we write like this, and this is area of triangle 2. Okay, area of triangle 1 and area of triangle 2. This is our ratio. Okay, that is equal to the corresponding sides have a ratio of 2:5. Now here in this question we have to be very careful. They didn't say square of the corresponding sides, they said only corresponding sides. Okay, so here if we want to find the ratio between the areas according to the theorem, we have to square them. So 4/25. So the ratio between the areas is a 4:25. Now this is the next question. The perimeters of two similar triangles are given here, 30 and 24. One side of the first triangle is 12. Determine the corresponding side of the second triangle. Now here what do we use? Now till now we were talking about areas. Now suddenly they started talking about perimeters. Okay, so if we have two triangles, one has an area of 30 and another has an area of 24. Okay, now we have to, how can we link it to the sides? Now for this we'll have to know another thing, that the perimeter of two similar triangles, okay, similar triangles, the ratio between the perimeters, okay, the ratio of the perimeters, okay, the ratio of the perimeters of two similar triangles is equal to the ratio of the corresponding sides. Okay, now here I want to remind you, it is not square of corresponding sides, it is straight corresponding sides. Okay, so this sum is actually a very small one if you know this particular theorem. Okay, so here let us then find it. So it is going to be a very straight question. So ratio between the perimeters is going to be this. Okay, and then one side of it, of the first triangle, is 12. Let the other side, if this side is 12, let this be x. Okay, so here we have 12 by x. So how much is it? First it is 6 4s are 6 5s are, okay. So now x is equals to 48 by 5, which is 9 and 9.6. Okay, so that is the length. 9.6 centimeter is the corresponding side of the other triangle. So sum is very simple, provided you know the theorem about perimeters. So actually, though I told two theorems, I had forgotten about this one. So this is actually the second theorem that we bring to use in this chapter. Okay. Now here they have one question in which they have a triangle A, B, C, and they have a line X, Y. Okay. Then they are saying AX is to XB is equal to 3 is to 5. AX is to XB is 3 is to 5, that is given. Okay, find the length of BC if the length of XY is 18. Okay, what do we have to find? We have to find BC if XY is equal to 18. Okay, and then we have to find the ratio between the areas of trapezium, the ratio between the areas of trapezium, the ratio between the areas of trapezium XBCY, XBCY and triangle ABC and triangle ABC. Okay, so these two things we have to find. Let's take a look at this again. AX is to XB, means if this part is 3 parts, this is 5 parts. BC, you have to find BC if XY is 18. Okay, and they have told that this line is parallel to this, that they have given in the figure only. Okay, so remember all these sums we are picking up from Selina. Okay, lots more to come up from Selina and lots more to come up from concise physics also. If you haven't subscribed the channel, you can subscribe it, because lots of question papers, revision question papers, solved previous year's questions will be done. So here this one is parallel. So the first thing I want to tell here is what people forget. Immediately they go into applying the theorem. Okay, but you should not be applying the theorem immediately. First, in 2 lines, we will just prove that these two triangles are similar. Which two triangles? This AXY and ABC. Okay. So how do we prove that the triangles are similar? This is a common angle. Angle A is equal to, I can say, angle BAC is equal to angle XAC. Okay, why is BAC equal to angle XAC? That is because of common. Okay, so the next one is this angle can be equal to this, or you can even take these two are equal. So angle ABC is equal to angle AXY, again corresponding angles. Okay, so these two are equal angles. Therefore, triangle ABC is similar to triangle AXY. Okay, by which property? By property AA property. If you write, it is more than enough. So first you have to prove this. Without proving this, don't go into the theorem. You will be marked wrong. Also, you will not get the marks that is given for this part of the sum. Okay, so now AX is to XB is given as AX is to XB is given as, this is given, okay, this is given as 3 is to 5. So let's do the rest now. First part is we'll have to prove the length of B. How much is BC? This is, if we take this as an X, if this is how much? This is given as 18, XY is 18. Okay, so first thing we will prove that. So what do we do? Here In two similar triangles, here we are not even using the theorem. In two similar triangles, we know that the ratio between the corresponding sides are equal. So, AX is corresponding to AB, yes, and in the big triangle. So, we are writing for the bigger triangle, we are writing in the denominator. So, here X, here 18 because XY is corresponding to BC. Okay, so because XY is corresponding to BC. Okay, now we are going to fill up how much is AX. This is 3 and AB in that case will be an 8. So, yes, okay. So, how much is the value of X? X is equal to 8 into 18 by 3 which is 48. Okay, so this becomes 48 centimeters. Let me write it here. If this is 48, the ratio between the areas of the trapezium, this XYBC, this and ABC and the big one is what we have to find now. Okay, so how to do that? Now be very careful, they told the trapezium and the big triangle. Okay, the trapezium and the big triangle. So how to work on this? Now this is one important calculation. Try to remember this kind of calculation. So straight away using the theorem, now we are going to go to area of triangle ABC, area of triangle ABC by area of triangle AXY. Okay, so AXY, we are just using the theorem. So triangle ABC's side was 48. Okay, so we will take 48 square and this is 18. Okay, so that is 18 square. Okay, now we are going to reduce it little bit and then work with it. So 48 into 48 and 18 into 18. Please don't multiply. I always tell in all my videos, please reduce. 6 3s are 6 8s are 6 3s are 6 8s are, that is 64 by 9. Okay, so I got my value as 64 by 9. Now what I am going to do? I am going to write AXY above. There is a reason. Triangle AXY. I'll just put it in the numerator. By area of triangle ABC, which is 9 by 64. Now what to do? Because I don't want AXY in the picture. ABC I want, but I want trapezium this. Now how do I get area of the trapezium? From area of the triangle ABC. If I can subtract area of this smaller triangle, I will get area of the trapezium. Now what I will do is area of triangle AXY by area of triangle ABC, just a -1 on both sides. Okay, I'll do a -1 on both sides. Area of triangle AXY minus area of triangle ABC. Okay, now if you are not being able to understand this, had they been just numbers, okay, so had it been 3 by 5 minus 1, I would have taken the 5 up here and this number would only have been the LCM. So area of triangle ABC, that only we are doing, but since we don't have the values, we have to work like this. Now that is equal to here 9 minus this is 64 by 64, which is equal to how much? 9 minus 64, that is a 55. So 55 by 64, but then minus. Okay, here also if you see that area of triangle AXY minus area of triangle ABC is actually a negative value. Why? Because ABC is bigger, this AXY is smaller. So here also when I write trapezium, I will get a negative value only. So negative area of trapezium, what? XYBC, okay, by area of triangle ABC, okay, that is equal to minus 55 by 64. Now I think I can cancel the minus from both sides. Did I get the ratio between the area of the trapezium to the area of the triangle is a 55:64. This does not cancel any further. This is in the lowest terms. So we will have to leave it like that. Okay. So this is our sum. This is the shortest possible way in which this sum can be done. If you check Selina, this sum comes as the fourth question in Selina. It's the fourth question in Selina. So I saw this is a special type of question. So I thought I will take up this question. All the sums that I am taking up in this video, I am taking up every type, okay, that can be made from this chapter. Now this is our next question. What is given? Given angle B is equal to angle E. These two angles are equal. Angle ACD, this angle, is equal to angle BCE. BCE, this angle. Okay. So this is what has been given. Okay, something else. AB is 10.4. AB. This is 10.4 and DE, that is 7.8. Find the ratio between the areas of triangle ABC and DCE. Okay, so now after giving so many things, they are saying this. First thing, again this mistake should not be done, is you should not take for granted that the two triangles are similar. How do we prove similarity between these two triangles is very important. Firstly, I can say angle B is equal to angle E, and that is given. But what about the second triangle? Okay, the second triangle, if I take this part as an x, then angle ACB is x plus angle ACD. This angle DCE is equal to again x plus angle ECB. Okay, that is BCE. Now, but then they have told these two are equal. You see, they have given these two are equal. Okay, therefore angle ACB is equal to angle DCE. This is, you have to write in bracket here, angle ACD is equal to angle BCE. Okay, that is given. So we can come to this. So we have finally got two angles, that is this angle equal to this angle, and these two are equal. So two angles, therefore triangle, this is ABC is similar to triangle DEC AA property. Okay, by AA property we have proved similarity. Only then we can start using the theorem. As I said, please don't lose marks by directly going to the theorem, prove similarity, because they never told it is similar. If they mention it is similar, go ahead with the theorem straight. Okay, so here it is, find the ratio between the areas of the two triangles. Now we are going to start with the finding the ratios. Okay, so area of triangle ABC, area of triangle DEC. Okay, area of triangle ABC, area of triangle DEC, that is how much. Okay, so here these two sides are definitely corresponding. You can even get it from the name ABDE. These are corresponding. Okay, in similar triangles or in congruent triangles, you understand like that. So this is 10.4 square, 10.4 square by 7.8 square. So that is 10.4. Please don't multiply, I am repeatedly telling. Okay, rather split them into factors and divide. Now this is going by how much? This goes by 13, 13 6 and 13 8 okay, so and there's a 0.6 and 0.8. So I am assuming that I have multiplied with 100 above and 100 below. Again 6 and 8. Now this is with a 2, 3 and 4 and 4 and 3. How much? 16 by 9. So the ratio between the two triangles becomes 16 by 9. Okay. Now let us come to the third theorem practically in this chapter. Now the third theorem says if there are two triangles from one common vertex, Yes, A, B, C. This is A is the common vertex. If there are two triangles from one common vertex and their bases are along the same straight line, this is one, straight line, then the ratio between their areas is equal to the ratio between the length of their bases. If it is so, then the ratio between their areas, area of this triangle to this, is the ratio between, if this is x and this is y, then the ratio between the areas of the two triangles, let's say triangle 1, okay, and this is triangle 2. So area of triangle 1 by area of triangle 2 is x by y. This is the theorem that we are going to use now in our sums. Okay. Now this is our next question, which says given BP is to PC is 1 is to 2. Okay. Now where is BP? This is a parallelogram. ABCD is a parallelogram, they have told, and ABCD is a parallelogram, and BP is to PC. BP is to PC is 1 is to 2. This part and this part. Area of the triangle CPQ. CPQ, though it is not there in the figure, still this area is a 20. Find the area of triangle CDP, this, and the area of the full parallelogram. Now how do we do this? Now here we have to use this theorem, which is based on just now the theorem I talked about. Now there are some triangles which are common vertex ones. If you note, it is, now before we start applying the theorem, we have to think like this. This full figure is a parallelogram ABCD. This angle is equal to this angle. Also, you can say this angle is equal to this. These two angles are equal. Therefore, triangle DPC and BPQ are similar. Okay. So, triangle PCD is similar to triangle PBQ, okay, by AA property. So first we will have to prove similarity. You write two statements and prove these two are similar. First finish that. Once you have done it, then the ratio here is 1 is to 2. That means ratio of this to this is also 1 is to 2. That is PQ is to PD is again 1 is to 2, because ratio of similar triangles are equal. Therefore, here also it is 1 is to 2. Now we will stop looking at these two triangles and we will start looking at these two triangles, which is DCP and PQC, because they have a common vertex C, okay, and the bases are lying in the same straight line. Straight line is DQ. Bases are lying in the same straight line. So this is the place where we will apply the theorem. So here now we can say area of this is 20. Therefore, area of triangle DPC, okay, or CDP by area of triangle, this is CPQ, okay, that is equal to, first CDP we note, so here we will write x, because this value, we are trying to find the area of this triangle, we will take it as an x, and by 20, okay. How much is the area of this is x, area of this is 20, but that is equal to the base ratio between the bases, and that is how much, okay. First we wrote CDP, the bigger one first, okay. So we are going to write 2 first. Bases are in the ratio 2 is to 1, so 2 by 1. Therefore, area x is 40 centimeter square. We got the area, that is the first part, we got area of the triangle CDP is 40 using theorem. Area of the triangle, area of the parallelogram ABCD. Now they are asking for area of the parallelogram. Now this actually connects us to something of 9th standard, in which they told if one parallelogram and a triangle are on the same base, here you see this is on the same base, okay, are on the same base, and between two parallels, the same two parallel line is only running here also, then the parallelogram is twice the area of the triangle. I repeat, if I have a parallelogram here and if I have any triangle which is using this base, okay, and this parallel, it ends here, this parallel, okay, I can have another one here also, okay, so then that triangle's area is half of the parallelogram's area. So based on that, we'll have to do the second part of the question, which is how much? So here 20 plus 40. Total area of this triangle comes to a 60. 60 if is the area of this triangle, then the area of parallelogram ABCD becomes how much? Becomes 120, double of that, 120 centimeters square. So this was one sum, little difficult I would say because we are using that theorem. Okay. Here we have a trapezium, and in this trapezium, name of this trapezium is ABCD. In Selina, this is question number 10 from that exercise. Okay. And then here they have drawn the diagonals, and these diagonals are meeting at the point P. Okay, they are meeting at the point P. Now they are asking in which in this trapezium these two sides are parallel, they have told us, then is parallel to DC, the diagonal bisect. If AP and is to CP, okay, now what have they given? Given AP is to CP is 3:5. Okay, then triangle APB is to triangle CPB. Triangle APB is to triangle CPB. We have to find. Okay, these are all finds. Okay, then 2. We'll have to find triangle DPC. Triangle DPC is to triangle APB. Okay, so these are the things we have to find. When AP is to CP is 3:5. AP is to CP, this is 3:5 is given to us. We have to find this. APB is to CPB. This APB is to CPB, this triangle. Again, if you see here, common vertex is here, base is 3:5. Therefore, ratio between the areas is how much is, I can say, is a 3/5, right? So ratio between the areas is 3/5 straight away because these are the bases, and APB written first, so 3 goes up. 3:5 is 3:5. DPC and APB. Now this is not common vertex. This is just a similar triangle. You see, vertically opposite and alternate angles makes these two triangles similar. So ratio between them is square of the corresponding sides. Now if you see opposite this angle, if I name this as x, this is also x. Opposite x is 5 and opposite x is 3. So these are my corresponding angles. This is how you should understand corresponding angles. So here area of DPC, first this. So that comes to square of 5, 25:9, and opposite these two make corresponding sides, that is AP and PC. Okay, ADP, you mean this, now it is this triangle, and APB, this APB, this is this triangle. Okay, so these two triangles are now, ADP and APB are now triangle ADP, this one, and APB, that is APB, this is this one. Okay, again we'll have to understand that this is a common vertex question. Now what is, this is the base, these are the bases. Okay, so here also once again the ratio between this side and this side, because they are the sides of these two similar triangles only. So this is again 3, this is 5. Okay, so common vertex, which one have they named first? ADP first. Okay, so now it is 5:3. straight application of ratio, no squares. Come to the last one, APB. APB, this one, and ADB. ADB, the big one. Okay, now they are saying APB and ADB. So once again, when I have APB and ADB, that is this full one. Okay, so that is now equal to, for APB, they are one triangle with a common vertex. So again, it is 3 for this one, but for ADB, it is this full line DB. Okay, so it is 3:8. Okay, so that is it. So that is it from this chapter of similarity. This was the relation between area of two similar triangles. Okay, so if you have liked the video, do not forget to like, share and subscribe. Thanks for watching the video. Bye then.